Hi, welcome to my channel pibyme Maths. This is Devan. In this video, we are going to solve May-June 2021 Pure Math 2 paper. Let's look at question number 1. Okay, this is from Sequences and Series. Adina is saving money to buy a new computer. She saves $5 in week 1. Okay, in week 1, 5, not dollar, 5 pound, I guess. And then 5.25 in week 2, 5.25, 5.50 in week 3. So that's arithmetic series, and so on until she has enough money in total to buy the computer. She decides to model her savings using an arithmetic series or a geometric series. Okay, using the information given, but here we know it's arithmetic series, right? The common difference is the same. State with the reason whether an arithmetic series or a geometric series should be used. So part AI, there is a common difference. There is a common difference. So 0.25. Therefore, arithmetic series should be used. Used. Okay, write down an expression write down an expression in terms of n for the moment in pounds saved in week n. So this is week 1, week 2, week 3, week n, and week n is nth term, that's a plus n minus 1 times d, the common difference d. So when you open the bracket, you're gonna get 5 plus 0.25n minus 0.25. So it's going to be 0.25n plus 4.75. That's the answer for I. Let's move on to part B. Given that the computer she wants to buy costs 350 pounds, find the number of weeks it will take for Adina to save enough money to buy the computer. Okay, she is saving 5 plus 5.25 plus 5.5, 50, etc., right? The total should be equal to, let's say she is saving for n weeks, the total should be equal to 350 euros. So we need to find the value of n. Use the formula for sum of n terms, n over 2. Okay, this is the n terms actually, plus n weeks. 2a plus n minus 1 times the common difference is 350. And we need to frame a quadratic equation and solve it. So when you bring the 2 to the other side, you'll get n times 10 plus 0.25n minus 0.25 is equal to 700. Open the bracket, you are going to get 0.25n square. 10 minus 0.25 is 9.75n. Bring the 700 also this side. That's a quadratic equation, right? Okay. So let's say we divide everything by 0.25. Okay, 39. Okay, I'm going to divide everything by 0.25. So n square plus 39n minus 2800 is equal to 0, which is a quadratic. I'm going to solve the quadratic now. 1 plus 39 minus 2800, 36.8. okay, n is 36.89 ... and the second value is a negative number, minus 75.88. n is the number of weeks, it cannot be a negative number. We are going to consider the positive number, but before that you need to write a step here. N is equal to minus b plus or minus square root of b square minus 4ac, everything divided by 2a. Okay. You see, n is the number of weeks. It has to be either 36 or 37. It cannot be 36.89. What does that mean? She will not save this money. She will not save this money in 36 weeks because she needs 36.89 weeks. That means 36 weeks and some days, not one whole week, right? So we can say, confidently say, in 37th week she will have this amount, not in 36th week, right? So you don't need to explain all this thing. You can simply write, therefore n is equal to 37 weeks. That's the final answer here. Question number 2 now. We have an exponential function with the graph given. Figure 1 shows the sketch of the curve with the equation y equals 4 power x. A copy of figure 1 labeled as diagram 1 is shown on the next page. Okay. Part A, on diagram 1, sketch the curve with the equation this 2 power x and 4 power x minus 6. They want us to sketch both on top of this diagram 1. Okay. First, let's sketch y is equal to 2 power x. Okay, look at this number. If the number is smaller, the curve will be like less steeper actually, but still it will pass through 1. This is going to be y is equal to 2 power x. Okay. If the number is bigger, let's say they want you to sketch 5 power x, it will be more steeper. This is 5 power x. Okay, remember that. And then one more thing, let's say they want you to sketch 1 over 4 to the power x, which is same as 1 power x is 1, 4 power x, you can put it in the numerator, 4 power minus x. You need to draw the reflection of this. That's going to be 1 over 4 to the power x. Remember that. Okay, anyway, we have sketched 2 power x already. And the next one is 4 power x minus 6. Y is equal to 4 power x. That's a given graph. When you subtract, when you put minus 6, you need to move the graph downward 6 units. But we have a horizontal asymptote here, right? We need to move the asymptote first. 6 units. So you need to put the asymptote here using dotted line. Always write the equation. Don't forget to write the equation y is equal to minus 6. And when you move the graph 6 units down, you will have the graph here. So the y-intercept will be 0, minus 5 now because it was 1 here, right? And then read the question. They want us to mention the point of intersection with the coordinate axis. That means you have to mention this point also. For blue one also you mention it as 0, 1. Okay. Now to find the x-intercept of the orange graph, you need to replace y by 0. So you're going to get 4 power x is equal to 6. So x is going to be log 6 to the base 4, right? So this point is log 6 to the base 4, 0. In the exam, you're not supposed to use different colors. So you use your pencil, but make sure you label the graphs separately. Y is equal to 4 to the power x minus 6. This is y is equal to 2 to the power x. And then put the points in the coordinate form. Part B, the curve with the equation 2 power x meets this curve at point P. Find the exact coordinates. They both meet at some point, right? But we are going to solve it by equating these two. 2 to the power x is equal to 4 to the power x minus 6. You move this also this side, so you'll get 4 power x minus 2 power x minus 6 is 0. I can write 4 power x as 4 is 2 square, so it's 2 to the power 2x, right? 2 to the power 2x minus 2 power x minus 6 is 0. If I take p is equal to 2 power x, p square is going to be 2 power 2x, so it can be converted into a quadratic actually, right? And then solving. So it's going to be 3 2s are 6. P minus 3 times P plus 2 is 0. P is equal to 3. P is equal to minus 2. So replace P back to 2 power x. 2 power x is 3. 2 power x is minus 2. When you use logarithm, x is going to be log 3 to the base 2. Here log minus 2 to the base 2. Log cannot be minus, so here no solution. So this is the exact x coordinate of the point P. So when you sub in this back into any one of this to find the y coordinate. So from here we know 2 power x is 3, right? So if x is this, so y coordinate is going to be 3. So you can write the point P of log 3 to the base 2, 3. Question number 3. Prove that for all single digit prime numbers P, P cube plus P is a multiple of 10. We are going to take all single digit prime numbers. For example, 2. So it's P cube plus P is 10. For 3, P cube plus 3 is 27 plus 3, 30. For 5, P cube plus P is 130, 125 plus 1. And then next prime number, not 6, 7. 7 cube plus 7. 7 cube plus 7 is 350. And then 8, 9, 10, that's all. So you can write 10, 30, 130 and 350 are all multiples of 10. Hence proved. This is proved by exhaustion actually. So we need to prove it for every single case. Show using algebra for n belongs to n, that means natural numbers. This is not a multiple of 3. Okay, let's expand this first. N plus 1 whole cube is going to be n cube plus 3n square plus 3n plus 1. How do I know that? We have this algebraic identity. A plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. Let's say we don't know this, you don't know this identity, you haven't memorized it. You know the identity for a plus b whole square or a minus b whole square, right? We don't usually memorize this, right? So you can do one more thing. You can write it 3 times and open the bracket, or apply binomial expansion. N plus 1 whole cube is n cube plus 3c1 n square times 1 power 1, 3c2 n power 3 minus 2 times 1 square plus 1 cube, which is n cube plus 3c1 is 3n square, 3c2 is also 3n plus 1, okay, minus n cube. So you are getting 3 times n square plus n plus 1. 3 times something plus 1 is always a not multiple of 3 because n are all natural numbers. Okay, so it's going to be a natural numbers. You are not going to get a fraction here or anything, right? So definitely, therefore, not divisible by 3 for all n belongs to capital N. This symbol is like for all. Okay, same like we use this for therefore, this for because. You can use this symbol for all, or you don't want to use the symbol, it's completely fine, just write for all n belongs to n. Question number 4, binomial expansion. They want you to find the expansion till x cube. So 2 plus x over 8 to the power 13 is 2 power 13 plus 13c1, 2 power 13 minus 1 second term power 1, 13c2 2 power 13 minus 2, second term power 2. 13C3, 2 power 13 minus 3, second term power 3. Now we need to carefully expand it. 2 to the power 13 is 8192 plus 13C1 is 13 times 2 to the power 12 is 4096 times x over 8 plus 13C2 is 78 times 2 to the power 11. 2 to the power 11, which is 2048 times x square over 64 plus 13C3, 286 times 2 to the power 10, that's 1024 plus x cube over 8 cube. That's 512, and then in the next step simplify and write the answer. So in the next step you can write, it's going to be 8192 plus 13 times 4096 divided by 8, 6656, 6656x plus. Now 78 times 2048 divided by 64 is 2496x square plus the last term is going to be 286 times 1024 divided by 512. 572 x cubed. That's the expansion. Part B now. Use your answer from part A to find an approximation for this. Okay, I'm going to put the answer from part A here. This is the answer from part A. Okay, first of all, this is the expansion of 2 plus x over 8 to the power 13, right? Since this also has a power 13, equate this so you can get the value of x. Remove the power. 2 plus x over 8 is equal to 2.0125. Subtract 2 both sides. X over 8 is 0.0125. So x is 0.0125. 0.0125 times 8. You get 0.1. What does that mean? When you sub in x is equal to 0.1 here, you will get this. So to find the approximation, you need to sub in the same value into the expansion. So below you can write the working. 2.0125 power 13 is 8192 plus 6656 times 0.1, 2496 times 0.1 square, 572 times 0.1 cube. Get the answer, right, round it to 3 decimal place. So 8192 plus 6656 times 0.1 plus 2496 times 0.1 square plus 572 times 0.1 cube. Round it to 3 decimal place anyway. 8883.132. That's the answer for part B. Part C now. Without calculating this, state with the reason whether the answer to part B is an overestimate or an underestimate. Okay. How did we get the answer in part B? We have taken this is equal to, we sub in x is equal to 0.1 in this expansion here, right? Basically this. 572 0.1 whole cube. To find the approximation of this, in the binomial expansion, we replace x by 0.1, right? But did you notice something here? Okay, we don't need two equal sign actually. In this binomial expansion, all the terms are positive, right? All the terms are positive. That's important because we got the value 8883.132 when we added these four terms. So if you add the fifth term, you're gonna add some number here, so the value will get bigger, right? The value will become bigger. If you add one more term, again you're gonna add another positive number, the value will get further bigger number, right? A bit more bigger number. Since we have taken only four terms, what we have here is the underestimate, because we have taken only four terms, and not only because of that, all the terms are positive. So you need to write that actually. Since all the terms are positive in the expansion, the estimation in part B is underestimate. Why underestimate? If we take one more value, this will increase, right? Okay, but this condition is very important. All the terms are positive. But what if the terms are not positive? Let's say you have a negative sign here, positive here, negative here. So when you add the next term, you're going to add something. When you add the next term, you're going to subtract something. So in that case, we can't really say what we have here is underestimate or overestimate. So they will ask this type of question only when all the terms are positive, and you need to mention that in the answer. That's the reason actually. They want you to state with the reason. So you need to mention the reason that all the terms are positive. So the estimate we have here is underestimate. Question number 5. We have a diagram with curves C1 and C2. Shows a sketch of figure 2 shows a sketch of part of the curve with curves C1 and C2. Curves C1 intersect at x is equal to 2.5 and 4. Okay. And then the table of values for some points on C1 is given. Use trapezium rule with all the y values. Find two decimal places. The estimate of the area bounded by the curve, the two lines. Basically, they want you to find the area, not R actually. They want you to find this whole area using trapezium rule, not just the shaded region. So when they ask you to use the trapezium rule, the first step you need to do is you need to show the value of h. H is the common difference, which is 0.25. And then write the area. Area is equal to, using trapezium rule, h over 2 times the first value of y plus the last value of y. 5.453 plus 5 plus 2 times sum of the rest of the y values. 7.764, 9.375, 9.964, 9.367, 7.626, and get the answer to two decimal places. You have to be very careful when you plug in all these values into the calculator. Okay, 0.25 over 2 times 5.453 plus 5 plus 2 times, I'm going to open the bracket second time, so I need to close it 2 times actually at the end. 2 times the sum of the rest of the values, 7.764 plus 9.375 plus 9.964 plus 9.367 plus 7.626 close the bracket again. They want the answer to 2 decimal place, so 12.33 is the answer. That's basically not the shaded region, the yellow one. That means the whole region below the curve C1 from 2.5 to 4. The curve C2 has the equation. They want you to integrate it. So it's going to be integral x power 3 by 2 plus 1, which is 5 over 2 over 5 over 2. 3x square over 2 plus 9x plus c. That's all. You can just tidy this up, write it as 2 over 5x power 5 over 2, 3 over 2x square plus 9x plus c. Okay. Part C. Find region R. The region R shown shaded is bounded by 2 curves. From answer, use your answer from part A and part B to 1 decimal place. Find the estimate of the region R. Okay, it's very simple. We have calculated 12.33 here. That's this yellow area. 12.33. In part B, we integrated curve C2, and when you sub in the limits, we are going to get this area and then subtract them both. So we are going to take this integration, sub in the limits now. So you can write area below the curve C2 is equal to, take the integral from previous part, 2 over 5x power 5 over 2 minus 3 over 2 x square plus 9x, don't put plus c, sub in the limits 2.5 to 4. Okay, 4 to the power 5 over 2 is 32 times 2 over 5. 64 over 5 when I sub in the upper limit, minus, when you sub in here, 4 square is 16 divided by 2 is 8 3s are 24, plus, when you sub in here, 9 4s are 36, minus. Okay, now we need to sub in 2.5 now. 2.5 is basically 5 over 2. We need to try to get the exact value. So let's say I put 2.5 to the power 5 over 2. Oh, okay. So what I'm gonna do, do not worry, they want the answer to 1 decimal place, so it's completely all right. So I'm gonna sub in the lower limit now and find this whole thing. Okay, so first find 64 over 5 minus 24 plus 36. Okay, 24.8. I'll keep it as 124 over 5 minus, you write a step first, 2.5 power 5 over 2 minus 3 by 2, 2.5 square plus 9 times 2.5, get this answer. Okay, 2 over 5 times 2.5 to the power 5 over 2 minus 3 over 2, you can put it as 3 over 2 or 1.5, 2.5 square, okay, square, plus 9 times 2.5. We got this answer, 17.077 dot dot dot. When we subtract this from 124, okay, 124 over 5 minus the recent answer, we are gonna get 7. That's not the final answer, that's basically the area below the curve C2. This answer, this area. Okay, now we already have the area below the C1, we need to subtract area below C2 now. Okay, area below C1 is here, 12.33. So you can write therefore R is equal to 12.33 minus 7.722. Round it to 1 decimal place. So what I'm gonna do, 12.33 minus the recent answer, 4.7 4.6 to one decimal place, 4.6 square units, because we are talking about area here.